Hello everyone, good afternoon. This is Kumar here with Ingram Micro. Today we will be speaking about communications and network security. It's a very broad topic, but I've tried to limit the content so that we can cover it within 1 hour as part of the CISSP modular training. So, and also one more thing to add, please be vocal and do speak out whenever you have any questions. Let's have an interactive session rather than a one-way one. All right, this will be today's agenda. I hope everyone can hear me and can see the screen. Okay. Let me stop this sharing and share it one more time. All right. This is our today's agenda. There will be the objectives of this session. There is an introduction about CISSP, as we do it with other sessions as well, and the list of topics that is going to be covered as part of today's session. Deep dive into the topics, of course, and we will also be looking at the Ingram Micro's cybersecurity portfolio, so that you'll be aware of Ingram Micro's capabilities when it comes to cybersecurity. So the objective of this training is to provide you an overview about the communications and network security domain of CISSP. This is not in any way a full-fledged training. This is going to be a very high-level view given the limited time we have today, so that you'll be familiar with certain communications and network security concepts. So, introduction to CISSP. CISSP is one of the most premier and leading vendor agnostic certification when it comes to security professionals. It validates more from a deep technical and managerial skill of the professional rather than to say whether you are capable with a certain product or not. So this will provide you a in-depth view into security concepts, so that you will be able to design, engineer, and manage the overall security posture of your organization. It is usually a 3 hours exam. Initially, it was a 6 hours one. Now it is 3 hours, and it is a computer-based test. So you can go and write the exams from a Prometric Institute. And it's more like a 100 to 150 question exam rather than the linear format in the past. Now it is more about more of an aptitude kind of a thing, wherein it will the exam will end anywhere between 100 to 150 questions, and usually 700 out of 1,000 is the passing grade which is required, or the passing mark which is required. Some of the questions are there for testing purpose, some of them are not rated. This is usually the exam weightage based on the different domains. And today we are going to talk about communication and network security. And you can see that it is rated as a second one, and which also highlights the importance of communication and network security domain. These are the certification requirements. If you have to, anybody can write CISSP exam, but to become CISSP certified, it is not only required to pass the exam, but you should also have 5 years of work experience, at least in 2 of the domains. Or if you can remove 1 year of work experience if you have a 4-year college degree. And candidates who clear the exam and does not meet this requirement, they will become an associate, and they have 6 years to get the required qualification, and then they can apply for the certification and get certified. Once certified, there is something called CPE. You need to maintain your CPEs so that you can be certified for the future years, because every 3 years you need to ensure that you complete 120 CPEs. That is very important, along with an yearly membership fee. These are the list of topics that is going to be covered today. We will be speaking about network security, and we will also be talking about network components and their security. And we'll be talking about communication channel security which is related to the communication channel itself. And we will also be looking at some of the network attacks and their mitigations that can be in place to protect ourselves. Okay, let's get started. And before I move further, I hope I am audible. Just say an yes or no on the chat would be great. Or you can even unmute yourself and say yes. That's perfectly fine too. Fantastic. Thank you, Brown. And I also hope that you can see my screen. If not, just jump in and tell me. All right. So network security overview. So as I said earlier, it has the second highest weightage, this particular domain, communication and network security. And network security is one of the most, so network security is one of the most critical topics when it comes to security in itself, because we are living in an interconnected world, and security and the network devices and the components which are responsible for the interconnection has to be secured so that we will not be under any sort of an attack. And the technology changes has made our networking complex. So, and we need to ensure each technology is secured in a different way. And we should also ensure that different technologies work together. So we need to ensure our security, they are secure and they are interoperable. So if you look at security from and there is something called a CIA triad, which talks about confidentiality, integrity, and availability. So we need to ensure all these are met when we secure a network or the communications channel. There is no longer a clear-cut boundaries when it comes to network. In the old days, there were campus network. Now everything is LAN, WAN, everything is on the internet. And everyone's working from home. So everything should be there on the internet due to the current pandemic, current situation. So it all started with something called an OSI model. The network is based on the OSI model, if you look at it. So OSI model has 7 layers. So when we try to browse the internet, or when you try to visit a web page, it goes through all these 7 layers. So let's start from the bottom. First is the physical layer. Physical layer, it talks about the physical connectivity, the components which are required to enable the physical connectivity. It can be your LAN cables, it can be your hubs, it can be um, your wireless connection, anything for that matter. So that is all talks about the physical layer. There is no, the protocol regulation when it comes to that is more of an RFC based ones. The second layer is data link layer. This is where the actual data, the bits and bytes comes into picture. In the physical layer, it is only current flow, current connectivity, and things like that. So data link layer is responsible to regulate the flow of data from one system to another. It is responsible to error correction and to ensure the data is passed from one system to another system in the way it is supposed to be sent. Some of the protocols in this layer, one of the protocol I can talk about is ARP, Address Resolution Protocol. It is part of the data link layer. This is the layer where a switch would work, the network device switch. Third one is the network layer. This is responsible for end-to-end data transfer based on IP addresses. So in the data link layer, we have something called a MAC address. In the network layer, we have something called an IP address. So any IP-based communication happens on the network layer. For example, this is where a router would work. Yeah. So your IPv for the IP address we keep talking about works on this layer, and ICMP-based protocols work on this layer. Fourth one is the transport layer. This is the layer which talks about ports. For example, if you want to run different services from a single system which has only one IP address, you need the ports. So because IP address is going to be kind of the door to your system. But inside the door, once you enter, you can run different services or different applications on a same system or same IP address due to this ports. So let's say you are going to run two different websites on a same computer or a same host. What you can do is you can use two different port numbers so that it will be two different websites altogether. It will not be with the same IP address. So that's basically what the transport layer is going to enable you to do. And this is where something called TCP and UDP comes into picture. I'll talk about TCP and UDP and the importance of it. The next one is the session layer. This guy talks about, you can think of the session layer as a manager for all your communications. So it's going to talk about how to interact with different devices, interoperability. It's going to talk about when a session starts, ends, and how a session should be controlled. So that is what a session layer is all about. Presentation layer. This layer is primarily a how should I say it? It is more of a translator. So it is going to work translate machine dependent data to a machine independent data, and it is also responsible for cryptography. Something like, for example, the TLS and SSL we speak of, it works on this layer. So it translates data and it is responsible for communication between the application layer as well as the session layer. Finally, the application layer. This is all everybody can talk about or everybody can see in general. So the web pages which you see, the HTTP and HTTPS protocols which we always speak of, works at this layer. This is more of the graphical user interface or whatever you see on a browser. So think of that as the application layer. This is the layer which is responsible for whatever we see today, even the session, whatever is happening on the session, basically. So we have another model when it comes to networking. It is called TCP IP model. It is actually older than the OSI model, but it is how internet works. It's kind of a backbone of it. But OSI model gives you a granularity. So that's when OSI model, that is the main reason why OSI model was introduced, and it is being used as of today. This is a comparison between the OSI model and the TCP IP model. So you can see that the application layer and the TCP IP model is segregated as three different things. The host to host is taken care of. Transport, it's nothing but it's the same functionality. But the only difference is application is split into 3 in the OSI model. And transport layer is the host to host model and the TCP IP. Network layer is nothing but the networking, and the physical and data link layer are clubbed together as the last one, which is the network access layer of the TCP IP model. Okay, these are the 2 main protocols which everybody should know about. One is called the TCP, the other one is called the UDP. TCP is connection oriented protocol, and UDP is connection-less protocol. So having said that, I kept saying about the port numbers. So quick question for anybody can answer. Please jump in and answer. What is the port number for ping? So we all know about ping. We try to check connectivity by using ping, P-I-N-G. So does any one of us know what is the port number for ping? Anyone? Thanks, Himanshu. Anyone else would like to give it a try? All right. It is actually a trick question. So if you remember the previous slide, when I was discussing the OSI model, ping falls under the ICMP category. So if you look at it, it is on the 3rd layer. Let me go back to the slide really quick. Okay, there it is. So it falls under the ICMP layer. So this layer only works on IP address. Only the 4th layer works on the port numbers. So since ping falls under the ICMP category, it does not work on port. It works only based on the IP. It is responsible for IP to IP communication. So that is how ping works. So there is no specific port number for it. That is kind of a trick question anyways. Thank you both for your answers. Yeah. So basically what happens, as I said earlier, ports. So if you have only one IP address and if you do not use a port number, you cannot run multiple services on a single server or on a single host, basically. So that is to enable this, they came up with the port numbers. So with port numbers, you can run multiple services. You can run a FTP server, you can run a HTTP server. Within the HTTP server, you can run multiple websites, assigning different ports to each other so that they work the way it is more like creating instances to multiple instances in a single system. So that is what port numbers allows you to do. And there is a cap when it comes to port numbers. A system, there is only 65536 ports because it works on a 16-digit binary, and we all know it's zeros and ones, so it is 2 power 16, and that gives you 65536. So you have port 0 to 65535. There is nothing runs on port 0 in general. And the first 1024 ports are reserved ports. For example, if you take FTP, it is 21. If you take HTTP by default, these are the default port numbers which we are aware of. It is on 80. So these are called well-known ports or reserved ports. And anything beyond that can be used for any customization to avoid conflicts. These are some of the guidelines to implement network architecture security. First thing is, to implement security, you need to understand the OSI layer on the TCP IP models. So if you understand OSI layer properly, you can implement security at different stages. For example, at a data link layer, you can implement port security. you can establish point-to-point protocol. From a router layer, you can enable routing related security. At TCP layer, you can implement a proper firewall, which does filter out ports and allow things. So first thing is we need to understand OSA layer to implement proper security when it comes to that. And when it comes to network connectivity as a whole, also implement a network access control solution so that you know who is allowed to connect to your network. The next one we are talking about is you need to understand the vulnerability related to the networking protocols. For example, we saw the TLS protocol, right? So in the beginning, there was SSL, and now we are into TLS. So again, a quick question. So we still call SSL certificates. Does that mean that do we use SSL? Anybody can answer. So the certificates which we see on the web pages, we call them as SSL certificates even today. So does it mean that we are still using, is it okay to use SSL or we should only use TLS? Anybody? Yeah, SSL itself is not secure. Fantastic. We need TLS. Yes. Thank you for the answer, Ahmed. Yes, the reason is SSL, the protocol itself is flawed, and if you remember, there was something called Heartbleed, and when it came in, that's when people started thinking about, okay, there were so many vulnerabilities around it, and we need to stop using it. Heartbleed, that was related to SSH, OpenSSL based, and then there was the Poodle vulnerability, which was related to SSL. So SSL by itself is flawed, so we should not be using SSL any longer. Ideally speaking, we should be using TLS 1.2 or above. That is the recommendation from a security perspective. So it's called TLS 1.2 to say it again. So if the reason why they still call it SSL certificate is, even though we use TLS as the protocol, that the name, it started as SSL certificate and people were convenient, and we are still calling it. So even though it's just a certificate, it's called public key cryptography. That is again not a common term to say. It's a public key certificate rather than an SSL certificate, but people started using SSL certificates as part of SSL in the beginning. So people still call it SSL certificate rather than a TLS certificate. So yeah. So these are vulnerabilities, as I said earlier. SSL has a vulnerability, so you should not be using it. You should be using TLS. So you should understand multiple vulnerabilities at different layers. So every layer can have a vulnerability. You need to protect all the layers across the OSI model, so that you will be aware of eavesdropping and denial of service attacks, so you can prevent all these things from happening. Excuse me, sorry about that. So you should also implement network and encryption protocols where possible at all layers. So for instance, at an application layer, use HTTPS instead of HTTP. And at a wireless layer or a networking or data link layer, use WPA2 to encrypt your Wi-Fi network rather than using WEP or WPA from the past, basically. The next topic we are going to talk about is network component security. So we are going to talk about network components to understand the different things which makes up the network and the security around this and some guidelines around it. So some of the networking hardwares are routers, which works on layer 3, which is the network layer, switches, which works on layer 2, which is the data link layer, hub, these are the physical ones, which works on the physical layer, modem, and the firewall. Firewall works on the layer 4. So these are the common network types. One is LAN and the other one is WAN. These are things which we are aware of. So there are two other things which are CAN and MAN. So LAN is nothing but the local area network, which is the office network which we use in simple terms. It can be within the single building or across the different floors. It can be wired or wireless in general. So LANs, wireless so you can always see wireless LANs. You will not see a wireless WAN, or to put it in other ways, we can do wireless WANs using the mobile networks, basically. CAN is nothing but campus area network, and a MAN is a metropolitan area network. These are for limited environments to and scale beyond a single building. So that is where the campus area network and metropolitan area network comes into picture. WAN is nothing but the wide area network. It covers long distances. Internet is also considered WAN. So these are the common network types which are out there and which are being used. So when it comes to transmission media or the physical interface, there are two interfaces. One is wired, the other one is wireless. So wired is your Ethernet cable, Cat5, Cat6, the other ones, the fiber optic cables, which you have there to connect two different systems, across the network. So, and wireless is your wireless things, and wireless has a greater risk for when it comes to eavesdropping. So you need to ensure encryption is there, and as I said earlier, ensure WPA2 is implemented. All right. So some of the guidelines to implement security on the network components are, one of the main thing is you need to ensure you enable, you need to ensure you harden all your devices, which means that you should have a baseline for the devices, and you need to ensure there is no default parameters set up before you commission or before you enable them on their environment. So you need to ensure all your routers, switches, firewalls are hardened as per global best practices. One such practice is available from Center of Internet Security. It's called CIS benchmarks. You can use that to harden your networking devices, and it is very important. For example, if you use the default router username and password, everybody is aware of it. And if you're going to still use telnet is an insecure protocol, so you need to use SSH instead of telnet. So that way you are hardening your network devices and preventing certain attacks from happening. And you need to use firewall-based VLANs to partition your network and segregate the traffic. So, for instance, if you are going to have a production and non-production environment, or a highly critical environments and a low critical environments, segregate the traffic so that even if somebody sniffs the environment using a server, the traffic will not propagate across. The critical system traffic will be within the critical environment, and the non-critical system traffic will not reach the critical environment, and vice versa. You need to always use firewall. The importance of firewall, I cannot stress enough the purpose of a firewall. It blocks all your unwanted communication. So you need to segregate your internal network from the internet, as well as your internal network within itself, as said earlier. So you should have a DMZ zone. You should have an application layer. You should have a database layer. You need to segregate your critical applications from a non-critical applications. So that way you are protected. So even if a non-critical environment is under attack, your critical environment is not under attack, rather than using a flat network. So firewall enables you. And as mentioned earlier, if you're having a public-facing server, ensure you place it in the DMZ zone on your environment. And use endpoint security for comprehensive protection. So just because you have a firewall on your network, that doesn't mean that your laptop is protected. Because do you remember, there is an application layer attack, or your server is protected. So ensure you have endpoint security deployed. Wherever possible, deploy host-based IPS, host-based firewall, and implement EDR solutions. So that's very important these days to protect against advanced persistent threat. And always secure all your physical devices against tampering or any accidents. So having a tamper protection lock, tamper alarm is good when it comes to the racks and other things. So ensure all your devices are physically protected and locked where possible. So the next topic we are going to speak about is communication channel security. So what is a communication channel? So when it comes to communication in itself, we spoke of the network and network devices, but then within the network devices, there is going to be a communication which is happening to transfer data. So it can be a voice data, it can be the presentation what we are working on, or any web HTTP traffic or FTP traffic. So it is not enough only you secure the network devices, you should also secure the channel in itself. You need to secure your communications. So as I said earlier, you need to protect, you can protect your communications with HTTPS rather than using HTTP. And if you have a file server and you're going to use FTP, so try not to use FTP. Instead, try to use SFTP or FTPS for your file transfers. So there are many such solutions available to secure your file transfers. So go for them. And for example, if you're not, if there is a requirement wherein you can only implement HTTP for some reason, at least encrypt the channel in itself, for example, using VPN. So if you use VPN, any traffic which goes inside the VPN is encrypted. People cannot eavesdrop those traffic. So use VPN where possible. If you're not able to encrypt a connectivity at an application layer, you can still work it out by using a different layer, and that way you are going to encrypt the complete channel, and people cannot look at the traffic which goes inside the channel, basically. So remote access. So basically, this is one of the key areas we talk about, right? So these days, so remote access, the importance of remote access is never understated. So these days we connect to our office environment. Even today, I'm doing this presentation from my home. So accessing internal services without physically being there, it enables convenience. It is how the world is working today, even during this pandemic. So it is very much important to establish a mechanism to secure the remote access. So you will have a remote access server, for example, a VPN server. So you need to ensure you use a secure channel rather than just publishing your internal applications to the internet. It's where possible. So remote access security. So basically you need your users. So whenever there is going to be an application which will be accessed remotely, ensure you have strong authentication and authorization procedures in place. You need to have multi-factor authentication when it comes to sensitive information or critical applications. And especially when it comes to administrators, you should definitely have a two-factor authentication, because they are the highest privileged accounts for any systems. So, and you should also have protection to lock or detect and protect against a brute force attack. For example, as stated here, if there is bad attempts for a user account, you lock the account for some time, or you can lock it permanently so that someone else can enable it. But if you're going to expose critical applications, you can do that. At least if you do not want to do it, do not then and ensure that you at least lock it for a certain period of time, so that the same account will not be used, or a brute force attack will not happen using the same account. And there are many other mechanisms. If you feel that there is a brute force attack is happening, use a firewall device or to block the IP itself from the future attacks. So and if there is going to be a brute force attack, for instance, like a denial of service attack that is going to happen against an organization, use DNS protection providers so that your organization is protected during a DDoS attack or a DOS attack against your environment. Securing servers is very much important when it comes to remote access servers. The reason being is they are exposed to the internet. and they are kind of the first line of defense to enter your organization beyond the firewall. So anybody who is successfully able to connect to a RAS server, which means that he has bypassed your firewalls and he is inside your network. So you need to harden it, change the default password. You need to have update your patches, ensure firewall is there even at the RAS level. And you need to also enable posture checks and other things when it comes to remote VPN systems. And even after the RAS system, deploy a intrusion detection. Do not only depend only on the perimeter intrusion detection systems. Deploy an intrusion detection system for your internal network as well, so that you can identify any traversal attacks, any internal attacks within an organization. So these are some of the guidelines for implementing communication channel security. Always encrypt communications where possible. So ensure, so if you're going to do a collaboration session, ensure there is a password protected collaboration session so that people cannot jump in, log in, and eavesdrop into a session if it is a confidential session, basically. So for instance, the current session which we are working on, anybody can join in. This is more of a webinar kind of a session, so that it is a public facing session. So anybody can join in. It doesn't require a password. But if you are going to use a collaboration system session for an internal meeting, you need to ensure it is password protected so that an outsider cannot jump into your sessions. And always use VPN to secure remote access where possible. For example, if your user is going to use a public Wi-Fi, say public Wi-Fi is prone to man-in-the-middle attacks. So, and if they are going to connect to your internal environment using a public Wi-Fi, and let's say you do not have a channel security, if you are going to allow them to connect over HTTP, for example, any passwords which is sent over HTTP is going to be sent in plain text, which means that the password can be compromised. So if it is going to be a critical application, and if it is going to be an internal application, it is highly recommended to use a VPN to connect to your network, so that even if there are certain components which does not have security enabled, they will also be protected. And use software-defined networks where possible to have better control over your complete network or the communication channel as a whole. So any questions so far? Let me quickly look at the chat message. The cost of the exam, it varies from region to region. You can find the cost of the exam on the ISC portal, ISC2 portal. Usually it is around $600, but as I said earlier, it varies from country to country, region to region. So do check it on their portal. Any more questions before we move on to the next topic? Okay, sorry about it. I was on mute. I did not realize that. All right. So the next topic of discussion is network attack mitigation. So far, we spoke of security. Fantastic. Before we move further, let me also address the questions. So from my perspective, I work on SSL VPN. Okay. I will also talk about the, before I move further, I'll also talk about the questions which are raised. First thing is IPsec and versus SSL VPN. Both are secure. The only difference is how SSL VPN works. SSL VPN works at the HTTPS layer. It works over HTTPS protocol. IPsec VPN works on point-to-point protocol, basically. And both are secure if we implement it right. And the reason why SSL VPN is being promoted is that is the latest technology out there. And it is very easy to implement and configure SSL VPN. But if you look at site-to-site VPNs and things like that, IPsec is still used across. And when it comes to CPE requirements, CPE requirement has it is like 40 CPEs are required every year, and a total of 120 for 3 years. And out of this 40, it is split into two categories. Out of these 40 CPEs, it is split, as I said, it is split into two categories. One is Group A, the other one is Group B. Group A is more of a technical category, and Group B is more of a non-technical category. The good thing about CISSP is they want you to keep yourself up to date. That is the main reason for the CPE requirements. The Group A is more of a technical, as I said earlier. Yeah, it talks about technologies, security-related things. It talks about the involvement of you against domains. You can attend sessions, and again, CPEs. There are multiple sessions available. You can take some exams, which are also available. Reading some magazines, technology-related magazines, which are available to gain CPEs. So that is part of the Group A. Group B is all about your individual growth. You can learn anything. For instance, once I learned Japanese, I went through a Japanese course or a psychology program to get the Group B points. So you can do anything when it comes to Group B. You can attend JISEC, and you can attend a security conference, for example, and you can claim your Group B points. So that is possible out of the 40 points. Again, out of the 40 points, Group A takes 30 points, which is related to technology. Group B is more of a general point, which is 10 points. So OpenVPN, again, as I said, it's a concept. So OpenVPN, if you look at it, inside OpenVPN, you can configure IPsec or SSL VPN. So OpenVPN is more of a concept, and you can use anything when it comes to the protocol in itself. You can configure SSL VPN or IPsec within OpenVPN. All right. Fun fact, is using VPN illegal? Or when does, to ask a question in a different way, when does using VPN becomes illegal? Does anyone know? Using VPN itself is not illegal, but if we are going to use VPN to bypass certain aspects which are blocked by a country, that is where it becomes illegal. All right. Now, the last topic. I believe those are the questions. If you have any, please do keep it coming, and then I'll come back to the chat again so that I can clear what are the questions you have. The last topic is network attack mitigation. So far, we spoke of the security aspects of it, and as I said earlier, this communications and network security is a very big topic. I tried to give a bird's eye view of it so that everybody is familiar about the names. So far we spoke of the security aspects of it. The entire security, whatever we spoke of so far, is to prevent any attacks. So these are mitigation aspects. Now we are going to talk about how we can mitigate. What are the different things we can do to mitigate attacks? And also we will also know about different type of attackers out there, what they do, different process that is involved as part of an attack, again at a very high level. Defense in depth is the concept to prevent against any network attacks. The idea is to protect the data. Data is the most critical information, and you can protect yourself at all the layers. physical layer, network layer, OS layer, application layer, and data layer. You can prevent, when it comes to physical security, you can have tamper protection alarms to protect your racks, server racks, and other things. When it comes to network zones, this is the security which is covered by IDS, firewalls, and router. At OS layer, we have endpoint security and other aspects of things which can protect at OS layer. From an application layer perspective, having strong, very good configuration, ensuring the application does input validation and output sanitization, error handling at an application layer. These are all very important to protect application. From a data perspective, you can ensure that the data is always encrypted at all possible layers, even during transit as well as at rest. So data has to be encrypted. So these are some of the things which can be in place to prevent attacks from happening. So you need to follow a defense in depth concept. It is not like you protect one layer and all the other layers are protected. It does not work that way. So you need to have protection at all the layers, so to protect against any attacks. These are attackers, so usually white hat, black hat, gray hat, and blue hat. They are not attackers. The reason why it is mentioned over there is they are still going to attack, but not with a malicious intent. So white hat is somebody who breaks the system. So black hat, when sorry about that. So I was thinking about something black hat does. White hat is the only guy who is not considered an attacker without. The reason is he does not have a malicious intent. Blue hat or black hat does have malicious reasons. They do attacks to gain something out of it. Gray hat is these guys are like, sometimes they do it for personal reasons, sometimes they do it with a non-malicious intent. So those guys are called gray hat. Blue hat is generally these type of attackers try to find softer bugs to identify any 0 days so that they can be patched before everyone is aware of it. So elite hackers, these guys are experts when it comes to, they create programs, they find ways to break systems. So these guys are always programmers, they are very highly skilled. Hacktivists, these guys are activists, but since it involves computer hacking, they are called hacktivists. For example, they proclaim themselves that they do it for a cause. For instance, Anonymous is one of the activist group. They do that. It is not again recommended to be an activist, but they do it or they proclaim themselves that they do it for a good cause. So that is what activists are. Script kiddies are these are people who does not know about programming. They just go and use the tools which are created by a hacker, and they try to find some vulnerabilities out there in the open. These guys do not understand the how an attack happens or what is the what will be the result of an attack. So they just do it for fun. Newbie or noobs, these guys are beginners who are entering into the world of attacking or hacking in general. Nation state attacks, or these are something we have to be very careful about. These are attacks which are done by a country against another country. So these are called the cyber warfare. So we all know about warfare in general. These are cyber warfare, wherein this war happens over the internet or digital area. Organized crime groups, or these are crime groups which do hacking for profit in general. So these are some of the type of attackers out there who try to attack an organization. So this is the typical methodology of an attack. I'm not talking about the hacking principles. This is a summarized version of an hacking principle. They usually do a recon, and based on the information which is obtained as part of the recon, they do the attack, which is the penetration. And after the attack, they try to gain or maintain control of the target environment. So this is the methodology of an attack in general. So these are some of the things we can prevent or do to prevent the different stages of an attack. So one is recon. So always restrict the information which is available about your organization in the public. So that a hacker does not get information which can be used against an organization. And when it comes to error handling, ensure that if there is an error, it is a generic message which is returned. For example, if there is a password error, do not say your password is invalid. Rather, tell them that it's either your username or password is invalid, so that people do not know whether the username is available for the system. And whenever there is a HTTP error, for example, on a website, give them a generic error saying that the system is not available, instead of the default error which gives the Apache server running on it, the version of the system, and other things about the application server, so that people are not aware about the system which is running in the background. Always protect your systems using firewalls and intrusion detection mechanisms, so that if somebody is going to do a recon, for example, a port scan to identify all the ports that are available on your environment, those things can be identified early and prevented. So that way we are monitoring this any scans that is performed on your systems. You can also deploy honeypots. These are called decoy systems to find out, to confuse the scanner. And also if they are trying to attack your environment, this is usually done in a very critical environments, wherein they allow an attacker to attack the environment by using honeypots, so that they come up with solutions and prevention mechanisms against attacks. And always configure your intrusion detection system not only to detect any malicious attack, but also for sniffers in the environment. The second thing, or second stage of an attack, is the penetration based on the information they have collected. So to counter that one, even if they have an information, so an ideal solution should be, for example, it is not a bad practice to change the default port numbers, but ideally speaking, that should only be a complementary solution. You should have your system, even if they know the port number which is on which your service is running on, your system security should be robust enough so that they cannot establish a proper attack. So you should always physically protect your systems. That is the basic. You need to implement detection and protection systems, such as, for example, you can protect your web applications again application layer attacks by using a WAF solution, firewall to protect against transport layer attacks, IPS the same thing. It can detect intrusions within your organizations. One of the key things is to ensure the patches, ensure your patch management solution is robust in your organization. You need to keep looking for vulnerabilities, and you need to keep patching them whenever, as soon as a security patch is available. Harden your systems so that unwanted services are not available. You should enable strong authentication where possible. Implement multi-factor authentication. The application code should be robust. You should ensure always input whichever is received is validated, and output which is thrown back is sanitized, so that your application is secure and does not reveal any sensitive information. And always scan for rogue wireless access point within your organization, so that you will know if somebody has plugged in a rogue wireless access point, which can be used as a backdoor to enter into your organization's network. Always monitor your systems for malicious network and host activity. And finally, having said everything about protection, always have your critical data backup and in an offline location, so that the data is protected. Even if the data is lost, you have a place to restore it. These are the control countermeasures. So let's say even they have penetrated the environment, and you need to have mechanisms to protect, to have a reactive approach as well. So you should always practice both proactive and reactive. Reactive alone is not enough. Always practice a proactive approach. Like, for instance, do a penetration testing on your environment to know any flaws in the system, like an ethical by using a ethical hacker, for example. Reactive approach is more of monitoring to find anything unusual in your environment. So you need to implement both, that is proactive red teaming exercise, as well as reactive, which is like a SOC team in your environment. And turn off any unnecessary service that might, if it is not needed, turn it off, disable, uninstall the software on the server where possible. Disable it, do not run anything which is not needed. So if you're not going to use, for example, do not use insecure protocol like telnet, disable the service. If it is not installed, do not even deploy it on a system. Use secure protocols such as SSH, HTTPS where possible. And implement privileged access management. So irrespective of everything we do, if a user gets a hold of a privileged account for an organization, everything is at loss. So implement a privileged access management solution so that all the privileged access are governed and controlled. So these are some of the guidelines for mitigating against attack. This is more like a summary of whatever we have discussed so far. Implement defense in depth approach. Secure and monitor all possible entry points. Patch management is very important. Hardening is very important. As part of hardening, you need to remove all unnecessary things, services, ports, protocols, user accounts on a system, changing default configuration. That is one of the things. As part of hardening of your environment, implement strong authentication and access control. And always follow manufacturer's recommendation when it comes to hardening so that availability is also maintained. And try to automate. See, we need to start our protection at mission level speeds. It's no longer enough that we are going to be reactive. So we have SOAR in the environment. Implement SOAR where possible so that common activities can be automated so that attacks can be prevented at mission level speeds, mission speeds. So this is more or less of the topics for today. In the next few slides, we are going to talk about 2 or 3 slides. We are going to talk about Ingram Micro cybersecurity services portfolio, how Ingram Micro can assist you. So Ingram Micro has 4 aspects of it. So we call something called a discovery reports. We do discovery to find out anything sensitive which is available for. This is more like the recon phase of an attack. So we try to find information about an organization as part of our discovery reports. So anybody who's interested, do contact us so that we can run a discovery report to find out what is readily available about your organization out there in the open, how that information can be used to attack your organization. So by knowing it, you can better protect yourself. We have a virtual lab environment. What it basically does is whatever the security portfolio we have, all those systems are available for you to test it. You don't have to, if you want to do a POC, you can contact us and we can connect, we can integrate your solutions or do the POC in our virtual lab for you. You don't have to wait for a shipping, or you don't have to worry about your resources in the environment. We take care of it for you and you can do the POC and the use cases in our virtual lab. CyberGram is another utility which we have. It is an in-house built solution. What it does is it lets you analyze, it's a sequence of 28 questions. It lets you analyze the security posture of your organization. That's what CyberGram is. Multi-vendor architecture is what we do in general. We believe in a holistic solution rather than a providing a solution only for the requirement. So we try to protect across and cover all bases to protect an organization. This is our office in Dubai. We have our own set of cybersecurity experts. We cover from training, security assessments, consulting services, we do everything. So our holistic portfolio consists of people, process, and technology. It spreads across everything. For people, we offer trainings. From a process perspective, we do technical assessment, we do consulting services, and we also have managed security services when it comes to Ingram Micro. And this is the technology portfolio for the META region. We do support more vendors from an Ingram Micro perspective across the globe. These are the some of the vendors we have in the META region. These are our cybersecurity vendors. So that is it for today, and I believe we are on time. As I said earlier, this is a very high level thing, and we do have a dedicated training session for CISSP if someone is interested as part of our Ingram Micro portfolio. So before we say adieu, if you have any questions, please feel free to ask. Value of CISSP compared to others. Thank you, Imran, for the question. CISSP is most sort of certification when it comes to security. So if you want to gauge a person, it is very easy to gauge it if he has a CISSP. And to name one more thing when it comes to CISSP, it is now treated as a master degree in some parts of the world. Or rather than saying treated as a master degree, it is treated as equivalent to a master's degree. For instance, UK recently announced that it treats CISSP as a master's equivalent to that of a master's degree in the UK. So that is the value of CISSP, and no other certification has that value as of today. So if you have any more questions, please feel free to raise so that I can answer it. If not, thank you for joining today. I'm more than happy to. I enjoyed this session along with you guys. Thank you for your questions. Have a nice day and a wonderful week ahead. Cheers. Bye-bye.
Thank you, Kumar. Thank you, Kumar.